This year, we had a few goals we wanted to do. We want to solve at least 5 missions on the robot game board. We wanted to learn EV3 Python programming, and we wanted to host most of our meetings virtually because of COVID. So, to start out the season, we started making our new robot design in Studio 2.0. But at the end of the day, it didn't turn out so good. So we decided to use last year's robot. Its name is Marty.
We used 4 motors, 2 color sensors, and 1 gyro sensor that we had last year. This year, we tried to make less attachments, and 1 attachment that will do it all. The robot arm attachment uses the top 2 motors built into the frame. We designed our robot and attachment in Studio 2.0. We added extra weight to one of the robot arms so it can carry Bosch cubes. We created the Bobby Jr. attachment with rubber bands to push one of the kids off the slide while following on the line. We added rubber bands so the attachment won't get stuck on the pull-up bar.
We got help from one of our high schooler friends, and he taught us the basics of Python coding, data types, loops, and functions. Then most of us completed a Udemy course on EV3 Python by Professor Nigel Ward. We learned how to set up EV3 Python and Visual Studio Code. The course also introduced us to ev3python.com and online simulations. The first few months, it was impossible. We spent long evenings chatting with each other to find relevant documentation for the motors and the sensors. We stayed up late nights figuring out bugs in code. We learned to use online Python simulators like a posteriori and GearsBot so that we can code and test without the real robot. This worked out really well for us. The simulator does not work exactly as the real robot, but it allowed us to test the code functions and rudimentary robot run.
After a while, we started to recreate EV3 MyBlocks in Python. We recreated 9 MyBlocks as well as 1 Python-specific one, the robot stop. These MyBlocks were distance to degree, forwards and backwards acceleration, line square, PID line follow to intersection, wall square, and gyro turn. The acceleration move back and forward one was when we started the robot would start to slip and skid around the map. The line follow till intersection one is so when we come to an intersection, it will line square over there. And the PID line follow is to follow white and black lines.
Some of our functions were relatively easy to make in Python, like gyro turn or acceleration. Some of them were harder, like PID line follower, because if the steering became too high, the code would give us an error. We had an interesting problem with our line square function. For line square, you need to use both color sensors at the same time to detect the black line. In EV3 Mindstorm, it's relatively easy to do this parallel threading, but in EV3 Python, it's not so easy. So we took a dive into the world of multithreading. We learned all about multithreading from ev3pythons.com. We learned about multithreading and its commands like start and join.
We learned about the daemon, which allows us to stop the thread without getting stuck. It doesn't let us back to the thread or the main part of the code. We finally did line squaring using 2 threads to run 2 motors simultaneously. Another problem we found with EV3 Python is that it'll take the robot at least 30 seconds to start up. So we created a master code which triggers different codes based on the EV3 button that you press. Sometimes the robot would get stuck in pull-up bar or the bench. We can bring back the robot to home while losing 1 precision token, but if we had to restart the master code, it would take a full 30 seconds and we would lose all the time in our run.
We solved this problem by using threads. We created a thread in Python that will keep checking for the left button to be pressed. If the left button is pressed, it will stop the robot run without stopping the main master code. After figuring out our functions, we were able to go back to coding our robot runs. This year, we have 3 runs. They consist of the step counter, the pull-up bar, the Bokia cubes, the slide, the bench, and the basketball. Second run is our innovation project and health units. Our third run is the Bokia share, some more Bokia cubes, and finally, our robot dance. Thank you so much for your time.